Hey everybody, it's Easley from com, and today we'll be working on lesson 15. And lesson 15, I just want to focus on the mathematical basis of the tonalpohualli, or the Aztec calendar. And so we're going to start off with the Codex Borgia. Now, this is a Pre-Columbian codex that we've studied quite a bit already. And one thing I want to do in this lesson is really make it clear what the mathematical patterns of the calendar are, because I was listening to an interview of Ruben Ochoa, who, as you may know if you're familiar with the calendar, he kind of discovered the mathematical pattern in the calendar, and then used it to formulate a functional calendar that's aligned to the calendar of Tenochtitlan at the time of the Spanish conquest. And one of the things that he said on the podcast is that when he teaches somebody about the calendar, he always tells them to do homework, and that homework is to start with one xiuhpohualli, and then just write out all of the days throughout a year to see what the patterns are. Now, he lamented in the podcast that nobody ever does the homework, and so I thought, you know what, that would be a really good idea to do this Ruben Ochoa's homework for you and with you, so that you can see what he's talking about, because what Ruben's talking about is really, really important, and it's the whole basis of the calendar. And if you don't understand the math of the calendar, you know, there's really there's really nothing that we can we can do to prove to you, you know, that what we're saying is true. So it's really, really important that you learn how to do the math. And I understand completely that a lot of people are really bad at math. And you know, one thing I noticed in the field, people who study the Aztec calendar, a lot of times they're like historians or anthropologists or archaeologists, and most of the time those people honestly don't have a very strong mathematical background. People in social sciences usually go to social sciences because they don't have a good background in mathematics. And so I think that's one of the contributing factors as to why so many people have studied the calendar, and so few people have actually understood it, you know, because they're using Spanish sources, and instead of deriving the mathematical patterns themselves, they're trying to look for patterns without using the math, right? So and that's a really, really big issue. And so this is also kind of like an introduction to the calendar, because if you've never studied the calendar at all, you know, this is a really great place to start, because everything will come natural to you, and you'll see like, oh, how everything just makes sense. And, you know, you won't be as confused when it comes to things like, you know, the leap year and all those kinds of things, which I'm not going to get into at all. I'm just going to show you the mathematics of it all. Okay, so first of all, when we start with the tonalpohualli, okay, this book here, this is the beginning. This is page 1 of the Codex Borgia, and also drop a link to this book. This is a restored version of the Codex. If you notice, the one online, the ones you can find online are all like damaged and burned, but this is actually restored, so it's really useful. Although the artist who restored it did make a few mistakes, minor mistakes, but it's fine. So when we're looking at this, we want to understand that we're going to start with this. This is the first day of the entire tonalpohualli. Now, so if you, at this point, you probably understand how to read these Pre-Columbian books. And so we always start here. Okay, we're going to start at the bottom right, and then we're going to go this way. And so how we read this is, okay, this is a xiuhpohualli, this is a hecat, gali, quetzpalin, coat, miquisli, this is masat, tochli, at, Itzcuintli, Osomatli, Malinali, and Acat. Now, these are broken up into 1, 2, 3, 4, 5, 6 days on this side. And then there's 1, 2, 3, 4, 5, 6, 7 days on this side. Altogether, this whole line that I just read is actually 13 days. And so you'll notice these days were grouped intentionally as a group of 13. Okay, that was intentional. This book is designed to be read like this, open, right? And you're going across. And so one thing that tells us is there are symbols for, we call these the day signs. There are symbols for the day signs, and they're all different. And not only that, but there's 13 in one series. In other videos, you can learn more about this, but it just so happens that these symbols all are the Eastern symbols. So this is the Eastern direction. So when you look at our books, you're gonna see like everything's so organized so tightly, and there's so many different patterns that are formed as a result. So that's one. Okay, now we have 13 numerals. Okay, so we have 13, and that's given by this page here. Okay, there's 13 days. Now, there are not just 13 day signs, because if we turn the page, and this is designed to continue onto the next page. So we're going to go from Akat, and then I'm going to turn the page. And then we're going to continue here. And this is Ocelot. Okay, this is Cuautli, Cosca Cuautli, Olin, Tecpat, Kiawi, Xochi. One thing you'll notice, Cipactli was our very first sign. You see Cipactli here? Well, here it is again. Okay, and so what that's telling us is in total there are 13 numerals, and then there's 13, 14, 15, 16, 17, 18, 19, 20 day signs. Okay, those are two of the most sacred numbers in all of our culture, 13 and 20. Why are they sacred? Many reasons, but in this case, it's the exact basis of our calendar, the tonalpohualli, the count of days. Okay, so I'm assuming most people know that already, you know, 13 and 20. I'm showing you this because, again, this is a pre-Columbian codice, and even if we didn't have any Spanish, you know, documents or anything like that, or any other book post-conquest, we can look at this and figure out the mathematical patterns, which is the point of this whole video lesson. Okay, is not to rely on Spanish documents, because if we do that, it actually makes it so confusing that it'll make your head hurt and you'll want to give up. But it's a simple 13 day signs. Sorry, 13 numerals. Okay, 13 numerals. And then we have 20 day signs. Okay, so that is going to be, okay, so 13 numbers and then the 20 days. And again, we know it's 20 days because it repeats here, Cipactli, and then you'll see Ehecat and Kali. Cipactli, Ehecat and Kali. Okay, so since they're repeating, without reading any Spanish document, we can all understand that, okay, there's 20 days. And this is the order, this is the exact order of those 20 days, because they're always going to be in the same order. Okay, Ehecat is always going to be after Cipactli. They never change any order or anything like that. So we know Cipactli is first, okay? At all times, Cipactli is always first. That's a critical piece of understanding the calendar. Okay, not only is Cipactli first, but one Cipactli is first. This is going to be the beginning of the tonalpohualli cycle, which is a very sacred thing, you know, and I'll show you a little bit more about how we know it's the beginning. But I mean, all that Cody says, it always starts with what's Cipactli. This one is special because it has a complete tonalpohualli. So there's 13 days. Okay, And then there's 5 rows of 13 on every page. And so, okay, so again, this is math, right? A math lesson. So we're gonna go ahead and put 13 times 5. And this is gonna give us the total number of, in this case, their tonalli. Okay, the tonalli is the combination of the day numeral and the day sign. And so in this case, we have 65. Okay, I'll turn that over so you can see that. So I hope you're following me so far in the math. Again, if you hate math, I'm trying to go really slow so that we can all understand the patterns. Okay, so there's 65 days on this page. And so the next thing we need to do is figure out, okay, well, how many different pages are there? And we're going to multiply one more time. So this is, we'll count, this is 1 page, 2, 3, 4. That was the last page. So 4 pages, right? So then we're going to go times 4. And that's going to give us 260. Now, 260 is all of the total possible combinations of numerals and day signs for all so that's how many unique tonalli there are. So, for example, let's go back here. This is 1 xiuhpohualli, okay? But if I turn the page again, knowing that this is 13, okay, and then we're going to continue counting. We don't count 14, it goes back to 1. So it's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 xiuhpohualli. So that means that in all these 4 pages, the 260 days, we will encounter 1 xiuhpohualli, we will encounter 8 xiuhpohualli, we will encounter 9 xiuhpohualli and 2 xiuhpohualli until we have 13 xiuhpohuallis. And xiuhpohualli, you can see here. Okay, so this is one of them. This is yet another. So it could be 4 xiuhpohualli, for example, right? Just depends on the patterns. That here's another xiuhpohualli here. Now, if you count through, you will find there will be exactly 13 xiuhpohualli. In fact, let's do that together just to make sure we understand what exactly is happening here. So hopefully we don't miss any here, but I have 1. There's 2, 3, 4, 5, 6, 7, 8, 9. I have a feeling we're going to miss one or so. 9 and 10, 11, 12, 13. All right, I didn't miss any. All right, so see, there's 13 xiuhpohualli. So if you do the same, you can count all the other symbols just like that. Well, you're going to find 13 calli. You're going to find 13 osumatli. And that's again because it's when you multiply, you're multiplying 13 times 20. We did it in a different way because it was broken up in a different way. But basically you have 13, the numerals times 20, you're going to get 260 days. So that's another piece of evidence that shows us that there are in fact 13 numerals, even though unfortunately this particular codice does not actually show the numerals. You know, it would be a much easier thing if it was just 1, 2, 3, but unfortunately they don't show the numerals. They only show the day sign to represent that particular numeral. So I've seen people, you know, take these all, cut them up, put them on the wall, just to understand them a little better, because again, they're supposed to be read like this, and it's pretty difficult to to do that unless you have the actual book on the computer. It's pretty hard to do. But that's the basis of the entire tonalpohualli, which is the basis of our entire calendar system. So all you need to know is there's 13 numerals, there's 20 day signs. You multiply that, there's 260 days. And that's pretty much it. Because once we run this, I'm going to show you, I'm going to run all this in a Excel document, because otherwise it'll be really overwhelming and it'll take a really long time for me to count through these. Okay, but once we put it on the spreadsheet, and this is the reason why Ruben Ochoa suggests this as a homework assignment, is, you know, once you put it, take it from here, take the data from here, we have our understanding, and you put it on an Excel spreadsheet. Well, that's when you're really going to start to see the patterns, and it's really amazing how it happens. So let me just share my screen here. So right here we have this is the Codex Borgia. Okay, Codex Borgia is there's a debate. A lot of people think it's pre-Columbian, but it's not completely certain. And the biggest reason why is because there's Spanish writing on it. Okay, obviously the Codex Borgia that I just showed you had no Spanish writing. That's definitely pre-Columbian, but this one has Spanish writing. So it becomes a question of, okay, maybe it's pre-Columbian and then the Spaniards wrote after the fact, but then some people say, well, no, it looks like when they were painting this, they actually left a lot of space here for the Spaniards to write. And so that's one argument against that, saying that it's post-Columbian, and then you know, it was written in combination with the help of the Spaniards so they can write their information down. So it's unclear. I don't think it's ever been dated. So what we do know, however, is that the mechanism that we see here, and that whoever the artist was, they were really true to the native style. Okay, a lot of codices after the conquest are real like European style. Okay, but we have a lot of the Mesoamerican style still in here, which tells us it's probably a copy of a pre-Columbian codice. Okay, or it was somebody who was a writer from before the conquest. So anyways, the point is just to say what I just showed you in the Codex Borgia without the numerals. Well, here it's showing us the numerals. Okay, and this has a whole tonalpohualli also in the Borbonicus. You can get it free on my website. And this one has the numerals, which go up all the way to 13. They stop and then they continue on to 1. And everything we see here matches exactly what we see in the Codex Borgia. So we know what we're looking at, the pattern that we just derived is actually what was intended by the writer. Okay, so that's the Borbonicus. So let's go on to the actual spreadsheet. So I titled it Ruben's homework here. So what he says is, you know what? Just start. All you need to do is start with year 1, day 1, and fortunately we know what that is. It's 1 xiuhpohualli. We just saw that in the codex, and he says to run that through and on a spreadsheet and see what kind of patterns you come up with, and then from there you'll be able to derive everything that you need to know. And so let's see what patterns we see here. Okay, so 1 xiuhpohualli, 2 xiuhpohualli, again it goes to 13, and then it continues to 1, keeping in mind that there are not 13 descents, there are 20. Okay, so just like you saw in the book, you'll see it here, 14, 15, no, not 14, sorry. Yeah, well, we're talking about we're counting the day signs. So 14, 15, 16, 17, 18, 19, 20. Remember the short sheet is the last day sign, it's the 20th day sign. And then it goes to xiuhpohualli. Again, see how it repeats? And so like I told you, there's 13 xiuhpohuallis. Well, this is 1, this is 8. Okay, and I'm just going to show you 260 days. so we can see what happens at the end. And so as you can see, it's a lot of numbers, right? And again, we're still in year 1. And look what happens here. Okay, this is the 260th day. This is the last day in the Codex Borgia that I showed you. Well, since it's the 260th day, we have nowhere to go but back to the beginning, 1 xiuhpohualli. So in our calendar system, everything just cycles through, you know, starting from 1, and then you're going again. Now, the reason why we keep going is because the tonalpohualli, they always say, okay, it's the ceremonial calendar. It's only 260 days, so it's completely useless for a solar calendar because a solar year is 365 days. Okay, well, let's just see what happens if we continue on to 365 days. Because again, it's all convoluted. I'm trying to keep it real simple, trying to stick with the math, but we know that our ancestors ran this through. They did not stop at 260. They ran it through an entire 365 days. Okay, and I'll show you using the Pre-Columbian codices how we know that's true, but I already put it here to 365 days. So this is the 365th day. It says 366 because the first row is a heading. So it's actually 360. So this is the last day. Okay, 1 go up. That's the last day of the first year. If we ran those 260 days through 365 solar year. Now, watch what happens here. Okay, so we're gonna, again, we never stop. We just continue, we just keep going. And so since it's 365 days, the next day is going to be the first day of the new year, of year 2. And so it turns out it's going to be xiuhpohualli. A pattern that you should see immediately here is, well, we went from 1 xiuhpohualli to xiuhpohualli. Huh. They are going in sequential order. Well, that pattern continues. And year 3, we have 3 ozomatli, 4 coscacuatli, and it'll end up here in year 5 with 5 xiuhpohualli, and it's just going to continue counting up to 13, and it's going to start again on 1. Okay, so this is a we just derived another pattern just from the combination of 13 and 20 days, which is pretty amazing. We ran it through a solar year. So just alone, it may not seem amazing, like, okay, yeah, they're sequential, that's great, right? I mean, it's neat, but who cares, you know? It's just these days, what does that prove, right? A lot of people will say. Okay, so I'm going to show you these. This is alligator or crocodile. This is death. This is monkey, and this is vulture. It turns out that these 4 days, and this is what Ruben Ochoa discovered, you know, he's got a mathematical background, and so I always tell him, you know, you were able to discover this because of your mathematics ability. A lot of people don't have math ability. He always discounts that. He says, no, that's not true. Anybody can see this, but I disagree. I think that you have to have a math background, or at least understand the math of it. And some of you, I imagine, might have to like pause or rewind to really soak in the math. But yeah, I think mathematical minds can see this a little bit more easily. So Ruben Ochoa found this pattern. He says, okay, that's interesting. There's 4 different days, and these days repeat. If we continue on to year 5, 6, 7, 8, you're going to see it's going to be 5 xiuhpohualli, 6 miquisli, 7 ozomatli, 8 coscacuatli. So every single year is going to cycle through these 4 signs or tonali. And he started looking at the the Pre-Columbian codices, and he said, you see these 4 signs in everywhere, right? And so not only are they derived mathematically just from running the 260-day tonalpohualli through a whole solar year, but you see them everywhere in the Pre-Columbian codices. So that can't be a coincidence. There has to be, every time you see them, they have to be talking about the beginning of each of these 4 years, right? And so that was a major discovery, and that's a major aha moment. Like he said, okay, these 4 day signs have to start each of the years. And I'll show you a few of those pages. And if you saw the previous calendar episode, I went through this in detail. Okay, but I'm just gonna focus on those 4 signs. And so this is the, of course, the famous Aztec sunstone. Well, here's xiuhpohualli. Okay. And it's being pointed out by what is called the year bearer sign. This is the vulture. This is the monkey. And this is death. Those are the 4 signs that we saw. Okay, and they're being pointed out as year bearers. This is the first page of the Furjebre Meyer. Famous scene here. Again, if you saw the calendar lesson already, this is review. You got xiuhpohualli here. This is the alligator. Miquisli, death. Osamatli, monkey. And vulture. Now, one thing that you should note here in the order that I did this is it just happens to be the same order as the mathematical pattern derived it as. Remember, it says crocodile, death, monkey, vulture. Okay, let's go back here. Crocodile, death, monkey, vulture, same exact order. So now that we've derived it mathematically, we can use that to know the order. Well, it has to be in this order. Okay, it has to go in this order because that's the order that we just derived mathematically. So that's the correct order. And so there's a lot going on here, directions, and a lot of other stuff. But now, like, I hope you're starting to see, just by that, finding that one mathematical pattern, well, now we have a lot more information, okay, that we didn't have before. Here's another one. This is the codex called the Laud. And where's xiuhpohualli? There's xiuhpohualli here. And there's death and monkey and vulture once again. Interesting. These days are being singled out. Why? We know why. Mathematically speaking, they're the beginning of each of the years. Okay. Go back. One more. So this one is a really, really important one. We have xiuhpohualli is here, bottom right, and then you have death here, monkey, and vulture. Now, not only are they being shown here, one thing you might notice is that all of the other day signs are also shown here, right? They're all there, all 20 of them. And they're all there in the correct order. If you remember, it was xiuhpohualli, Aztec, Quetzalcoatl, and then the last day was Xochitl, flower. And so it's in the same exact order. So once again, that order matters. Like, you can't put them out of order. keep them in order. But one thing that is happening here is these 4 days are very different. They're being singled out by, these are some kind of being, haven't been identified, I don't think, but to me, they look a lot like priests, like what priests would look like. You know, priests would have the matted hair and black paint. So probably primordial priest of some kind. Well, they have a bonal tool. Bonal tool is used by the Teteo specifically to give birth. So what this is telling us is that these tonalli, these day signs that are being singled out, they are literally giving birth to each of the years. These are birth scenes, and so if you were born on one of these day signs, the Teteo would give you birth here, okay, with their bonal tool. The next one would present you to your family. The next one will cut your umbilical cord. And then the last one will give you your first earthly sustenance. And so we know the bonal tool is directly linked to birth. So here we have Quetzalcoatl, Tonacatlicuitli. This is Mictlantecuhtli, and I think this is Tonacatlicuitli, and this is actually Xochipilli. Okay, so they're giving birth if you were born in these day signs. So not only are these day signs derived from a mathematical pattern, but now we see they're extremely important. Every time these codices are talking about time and years, these are always singled out. Now the next thing is, this is page 27 of the Codex Borgia. So once again, you know, this is a really damaged version. So I'm going to show you the version that's not damaged. So again, this is the restored version. And again, this is a great opportunity to see the advantage of having a undamaged version, because it's just easier to read. And in this particular page, the artist did make a little bit of an error, but I'll show you what that is. So this is the page here. And so we have, so again, xiuhpohualli, alligator, Mequisli, death, Ozomatli, the monkey, and then we have the vulture, Cuscacuatli. Okay. Now, one thing that's really important about this page is each sign has an accompanying what we call a year bearer sign. This is flint. Okay, and this is akat, and this is tochli, this is kali. So this is telling us not only are these days the beginning of each year, but it's telling us that all the one Mequisli days, starting days, have to occur in one akat, years. This is what's called the year bearer. We know that because of the V sign on the back. Now, the mistake that the artist made is they did not put this year sign here, and they did not put it here. And so a little error. And the reason you saw the damaged version on my screen, well, that's the reason they did not see the pattern, and they did not apply the pattern. They're artists, right? They're not mathematicians. They're not going to notice the patterns like a mathematician would. Okay, so they filled it in incorrectly. But I want you to remember that, because This is telling us that the numerals have to match. And not only that, McKeesley has to go with the flint knife. Monkey has to go with the house. The rabbit also has to go with the vulture. And the reed always has to go with the xiuhpohualli. So let's go back to my spreadsheet. And so in my spreadsheet, we're going to be able to see this very clearly. Okay, so if we follow the pattern that we just saw, where the day signs match, or the day numerals have to match the years, and not only that, the year bearers have to match the particular starting day, it's going to look like this. So this is exactly what I just showed you. One reed always has to be in one xiuhpohualli. Well, two tekbat always has to be in two McKeesley. You see how the numerals always match? And the house is with the monkey, the rabbit is with the vulture. This is the flint knife with death. So these numerals always have to match. So yet again, another pattern that we derived. Okay, so this is a really important part in this lesson, because this is how the 52 years is also derived, because 4 times 13, 4 times 13 is 52. Okay, so 4 times 13 is 52. So what that's saying is there's 4 year signs, so it's these 4. If you notice, it repeats again with akat, so there's only 4 of them. And then you times that by 13 because there's 13 numerals. So you see how it goes to 13 and then it starts again at 1. So we're cycling through. And again, we know this specifically because of that page we just read, where the numerals have to match, and the reed also always has to match the xiuhpohualli. Well, it turns out that if we continue this this cycle, it's going to happen automatically. You know, the 9 xiuhpohualli is always going to match up with 9 akat. And so another pattern is 52 years. Well, what that means is, if you look through these, it's going to take exactly 52 years, because 13 times 4 is 52. So it's going to take 52 years before we come back to this exact point in time where 1 xiuhpohualli is in this exact location in the beginning of the year. That's how long it's going to take for us to cycle through. And you'll see on the 52nd year, it's Tochli, which is rabbit. So we know after 13, we start with 1. So it's going to be 1. And then the next year is akat. So it's going to be 1 akat, 1 akat. So every single important piece of the calendar is derived just by running 260 days through a solar year. And this is all the mathematics that we need to understand the calendar. If we're in a tekbat year, we know we have to start with McKeesley of the same numeral. If we're in a Tochli year, you have to start with xiuhpohualli. Now, as I mentioned so many times before, my blogs and my video lessons, there's no calendar that exists that this happens in, except the calendar that was in the Tenochtitlan at the time of the conquest. We know that that one did, and the Reuben-Ochoa correlation. Okay, so we know that the Reuben-Ochoa correlation is the only one that matches up with the calendar at Tenochtitlan. All of the other ones do not start with the correct day signs, because these people are not understanding the mathematical patterns, the patterns that we just derived through these simple tables and calculations. So it goes back to why are there 4? Why are there only 4 days that can start the year? Why not Why not 8 or 12, right? Well, our ancestors didn't even have a choice. They were following the math. They were mathematicians. There's literally only 4 options. If you keep running this through, you're only ever going to start the year with these 4. And so that's their extreme importance. It's not something where Ruben Ochoa said so we have to listen and trust him, right? No, it's a mathematical pattern that was derived. So we are obeying the mathematics. And when you see this pattern, you see that's the only way that it could be. If we start with 1 xiuhpohualli as day 1 of our calendar. And that's the same reason why there are only 4 year starters. Whoever designed this calendar, and this calendar is thousands and thousands of years old. Who started it? Nobody knows. But what we do know is whoever started it figured out this pattern. They said, well, you know what? There can only be 4 year bearers then in that case. Because if you have more than that, you're going to mess up the pattern. You match it up, the pattern stays tight, and you get that 52-year cycle. And everything just makes sense and it's predictable. Because again, all of the crocodile days will be on reed. All of the death days will be on flint knife. All of the monkey days will be on house. All of the vulture days will be on rabbit. To be able to do this and construct this and understand all the patterns that we just derived and how they connect together is amazing. The simple fact that they're using 13 numerals here, 13 numerals here, 20 day signs, and how all the mathematical patterns just become, from those combinations. We'll never know why they picked those particular numbers, why 13 and 20. I mean, obviously there was a reason that they did it back then, right? But that we'll probably never know. So here's the thing. We have to count without stopping in order to see these patterns. These patterns are present in all of the pre-Columbian codices that discuss the calendar. And it's deriving the mathematical patterns, again, is different from guessing. For example, a lot of scholars studying the calendar, a lot of them thought, oh, well, the year must start on these year bearers. Okay, so what they would do is they would look until they found 1 akat. Okay, and then once they found 1 akat, they'll say, okay, the year has to start on 1 akat. Why? Who knows? They're just trying to find a pattern, right? But that's the difference. That's what I'm talking about. The difference is, like, they're just guessing, right? Sometimes Spaniards write things too, like, oh yeah, the year started on the Kali, 3 Kali. They have to match the year bearer. And so that's how we know when somebody is guessing or somebody is relying too much on Spanish sources. If they're looking for something that's not there, this doesn't make any sense. 2 Tecbat cannot start this year because 2 Tecbat is going to be all the way somewhere over here, and there's no way that it's there. It is right here. Look, this is the 53rd day of the year. Why would we start the year on the 53rd day in the year? It just doesn't make any sense, right? And so I think that's where a lot of confusion comes in. If you understand this math that I just showed you, these patterns, that's all that you need to know. And you know so much more than most people who attempt to understand the calendar. And so one other thing I wanted to mention is that the 52-year cycle, if we're looking at this mathematical pattern starting with 1 xiuhpohualli, which, as we know, we always have to start with 1 xiuhpohualli, you'll see that after the 52nd year, we're going to restart on 1 akat. So mathematically speaking, and also originally, that was the new fire ceremony. New fire ceremony had to occur on 1 xiuhpohualli of the 1 akat year. Okay, that's just how it was. Now, again, getting into, you know, all of the post-Columbian confusion. The Mexica of Tenochtitlan, they did not start their 52-year cycle with one akat. They started with two akat, which is confusing. It's like, what? If you understand the math, you should be confused by that, right? Because two akat, and I've highlighted all the akats so we can find it easily, is way over here near the end of the 52-year cycle. So if we're starting at one xiuhpohualli, why would they start way over here, right? Well, two reasons. Before that, it was one tochli, and then there was a dust storm and famine that occurred in that year, and so the Mexica said, "Wow, that's not a good place to start our 52-year cycle. Let's change it to two akat." The other reason they did that is because two akat is actually the birth date of xiuhpohualli, or the tonali. Okay, and tree ring study was conducted, and sure enough, in that year, one tochli, there was actually a drought, and so they changed it, you know, because there's a drastic famine. So look, two akat, they changed it to two akat. That's the Mexica version. Well, before that, it was one tochli. Well, where did they get one tochli from? One tochli doesn't even make sense, right? In our work here. I didn't highlight one tochli, but it's somewhere in there. Where they got one tochli from? Most likely, just like the Mexica did with a lot of other things, they probably, here it is. They probably just, you know, carried it over from some other culture, maybe the Tepaneca. Okay, but it just goes down to they could, you could start your year or whatever, wherever you want, right? Like your 52-year cycle, you're just counting 52 years. So the fact that they're changing it so easily, you know, is not surprising. And so the fact that it's one tochli and two akat in the sources does not disprove anything. We have our mathematical pattern here. We know that one akat. So, you know, if you want to be a purist, if you want to say, well, I want to start the 52-year cycle on the year that was intended, this is the one that would be one akat rather than the Mexica two akat. Okay, so that's where it is mathematically speaking, the beginning of everything. So again, one xiuhpohualli comes back to the very first spot. And so that concludes this introduction of the mathematical patterns of the tonalpohualli. I hope you enjoyed this. And again, get your copy of the Codex Borgia, the restored version. I put in the YouTube link there, description. Thank you, everybody. And I'll see you next time.